1.34. We're given as our starting spot the absolute value graph, one from the toolkit function from section 1.1, and told to sketch a graph of h of x, which is defined as f of x minus 2 plus 4. Okay, well, let's see. If f of x is equal to the absolute value of x, then f of x minus 2 plus 4 would be equal to the absolute value of x minus 2 plus 4. So really this thing h of x that I'm attempting to sketch is this guy. And you don't have to go through all this work to write it like this, because you can apply all your transformations, arguably even easier, written in this form right here than in this form right here. They look pretty similar. In this case, I applied the function, which is the absolute value. In this case, we leave the f of in here. But I want to do this because sometimes it's nice having actual numbers. It can help you check values. You can plug in points for x and y and make sure that you're right. So I want to show you how you can get from there to there. At any rate, really what you're supposed to recognize when you stare at this thing is that you have two different transformations going on right here. This minus 2 is one transformation, and this plus 4 is a different transformation. And the minus 2, I'm subtracting 2 from the x coordinate, so that's a horizontal transformation. The plus 4, I'm adding 4 to the f of x, so that's a vertical transformation. And if you go back to your little cheat sheet, see if I have that somewhere, this guy, what I have is this type of transformation and this type of transformation. I have one vertical shift and one horizontal shift. In one case, I'm going to add a number to all of the y coordinates, and in the other case, I'm going to subtract a number from all of the x coordinates. And those numbers are -2 and 4. So I'm going to add 4 to all of the y coordinates. Maybe I'll even write this, add 4 to y's from this guy. And I'm going to subtract -2 from the x's. Wait, subtract -2, that's a complicated way of saying that. Yep. You can also think about that as adding +2. But I wanted to write it as subtracting -2 because I think it helps, even though that seems unintuitive, to say subtract -2, because then you don't have to worry about remembering which operation you use in which case. You remember that horizontal shifts, you're always subtracting. It's just sometimes you're subtracting a negative number, which is equivalent to adding. At any rate, once you have all that information, all you need is your starting spot, f of x equals the square root of x. What I'm going to do is use this prior example. And so this was the answer from the last example. But ignore that, pretend that's not there at all. Here's the starting spot, f of x equals the square root of x. And from this, it would be easy enough for me to add 4 to the y's and subtract 2 from the x's. Let's label some points. Here's a point at 0, 0. If I add 4 to that y coordinate, well, the y coordinate was 0. That moves it up here. And if I subtract 2 from the x coordinate, the x coordinate was also 0. 0 minus -2 is +2. That brings me right here. This point goes to here. And really, that might be enough for you to graph the thing right now, because I don't change the shape at all. But just in case it's not, let's pick a couple more points. I have a point right here at -1, +1. The x-coordinate is -1, the y-coordinate is +1. If I add 4 to the y-coordinate is now at 5. If I subtract -2, aka add 2, to the x-coordinate, I'm taking -1 and I'm adding 2 to it. That would move me over here. If you do the same analysis with this point, you'll see that it ends up right here. And that's enough for me to kind of see the shape of this thing. Wow, it's hard to connect. It's hard to draw straight lines on a computer. I'm going to go ahead and call that good. I'm going to call that h of x from this problem here.